Hello again, students. In this unit we've been working with performing operations on rational expressions. Well, in this mini lesson we're going to learn how to multiply and divide two or more rational expressions. Now before we get into the actual multiplication or division, we're going to look at how we might simplify a rational expression first, such as the one you see here, x squared minus 2x minus 15 all over x squared minus 9. Now, some of you, your first instinct as you look at these, you might see that there's an x squared in the numerator and the denominator, and you might get excited and think, oh hey, x squared minus, or divided by x squared is 1. I can cancel both of those. You would be completely wrong. That's not the case. The reason is that this x squared and this x squared are both part of a sum and not a product. I can't cancel or divide out a common factor if I'm talking about a sum. Now, to show you an example with numbers that I think will make more sense of this, consider the expression 3 times 5 divided by 5. Well, as you look at this, I am multiplying 3 times 5 in the numerator and then dividing by 5. Well, obviously if we were to actually multiply this out, 3 times 5 is 15, and 15 divided by 5 would be 3. Now, we wouldn't have to go to the trouble of multiplying 3 times 5 if we notice that there is a common factor of 5 in both the numerator and the denominator. We can divide out that common factor, or I like to say cancel. 5 divided by 5 is 1. So it would be 3 times 1 over 1. Well, 3 times 1 is 3, divided by 1 is 3, so I wouldn't need to have this 15 over 5. I could just say that this expression equals 3, and that's it. Would the same be true if I had 3 plus 5 divided by 5? Well, if your instinct is telling you, well, I see a 5 over a 5 and I cancel it, well, that means I've got 3 plus 1 over 1, and that's 4 over 1, so that's 4. Would that make any sense? Is that true? I don't think so, because this expression is supposed to be 3 plus 5, which is 8, then divided by 5. Does 8/5 equal 4? I don't think so. So the next time you think, oh, maybe I can just cancel it, make sure that it's a product and not a sum. Now, I would like to cancel a few things with the expression that we see, but in order to do that, I have to have products, not sums. Well, in order to take a sum and turn it into a product, I will use factoring, something that we've practiced extensively. If you need to use the British method to help you factor an expression like either one of these, please feel free. So as I factor the numerator, x squared minus 2x minus 15 can be factored into the product of two binomial factors, x minus 5 and x plus 3. My denominator, x squared minus 9, I notice that that is a difference of squares factoring pattern that I can apply. I'll factor that into x minus 3 times x plus 3. Now, the expression in blue on the right, I have a product in the numerator, one thing times another, and a product in the denominator as well. Because I have a product in both numerator and denominator, now I can look for common factors and divide them out or cancel them. Well, you'll notice that x plus 3 is a factor of the numerator and the denominator. Therefore, I can go ahead and cancel that common factor, x plus 3, which leaves me with a numerator of x minus 5 over x minus 3. Now, can I cancel x over x? No. X minus 5, that's part of a sum. So is the x down here. It's part of a sum. So is that one. We can't cancel any further. This is as simple as that expression will get. We'll go ahead and stop right there.